Ladies and gentlemen, welcome back to another live stream. Alright, so please join my Discord server. You can find the link down in the description below. So just a disclaimer, this I'm not very advanced at Bevy, yet, so this is just gonna be a live experimenting with Bevy and Lua JIT. So yeah, let me share stream, everyone. Live. Alright, cool. Let's go. Hello, Loop Luminary. Welcome back to the live stream. How is it going, man? Every time you're the first. Okay, let's go. Let's go. Alright, so I just set up a little scene right here. Now, I did make actually a stream experimenting with Lua and Bevy before, one stream, which I actually made private because it was such a big failure. Due to a lot of reasons. The first reason that I wasn't really experienced with this stuff like at all. And the second reason was where the very slow compile time and runtime of Bevy engine. With Rust. So I actually fixed all those problems, right? So let me show you. Here I have just a little simple 3D scene example from the Bevy examples. So if I run this, this is what I get. As you can see right now, it's very fast in runtime. I got this world inspector, which I could see all the components, the entities, and so on. This is just, I added it just for debugging purposes, so let me show you how this is all set up. So first of all, my cargo.toml, I have Bevy, and I'm actually not using the latest version, which is 0.14.2. I'm using 0.14.0 because if I want to use plugins like other community plugins of Bevy, like Bevy Inspector EGY here, most of them right now are actually using 0.14.0, so I'm just using that too. Right, and then we have here features dynamic linking, so we can dynamically link the Bevy game engine, which is way faster to compile and so on. And here, of course, I have the Bevy Inspector EGY plugin, which actually gives me that window which I can inspect entities, components, and so on. Great for debugging. And also you could actually edit stuff. Let me show you real quick here. If you actually, let's say, go to resources, maybe clear color, and then you can actually change this however you want, as you can see, which is very useful for debugging. The other thing is the log here. So I added log with version, doesn't matter the version, it would basically pick it from the version that Bevy is using. And the features, this is what's important: max level debug and release max level warn. This basically, or effectively, disables the logging of Bevy entirely, right? So it would be way faster. Otherwise, if you don't add these, then what happens is that the logging is still there, it's just disabled. It's just not really disabled, but it's just filtered, right? So it's still there in the runtime, but it's just not going through to your terminal to see it. So yeah, mlua, of course, mlua, I'm using the latest version, and I'm gonna be using luau JIT, which is the luau is like the Lua version that Roblox made, and it's way faster and way more effective for game development. They also have a sandbox mode, which is very useful. And of course, we're using even the JIT version, which is very fast, comparable to the C runtime speed. So yeah, here we got profile.dev optimization level 1. So this is for let's see, so we're just basically making the optimization level 1, so the compile time is faster for our package. And for the development packages, so the dependencies, we're actually setting the optimization level to 3, meaning our dependencies would be compiled at full, at release mode kind of, right? And then here, these are just for release stuff anyways. So that's basically it for cargo.toml. Rest, by the way, I'm gonna probably publish this at the end of the live stream. I'm gonna publish this, and then you can go to the first commit that you're gonna find, and you can, if you wanna go and like basically follow up with my live stream here and code along, then you're gonna find the first commit having all this stuff set up, right? So Rust dash toolchain, I'm also using the nightly Rust toolchain, which is faster and yeah, better, I guess. Anyways, what else? We also have .cargo config.toml. By the way, let me actually share the stream in the Bevy server. Why not? Hold on, forgot about that. So Bevy engine streams, there we go. So this was the previous stream, but I just made it private, as I said. So yeah, alrighty, cool. So let's go back. So here we have, hold on, where's the chat? There we go. Hello, Theo Paris, welcome to the live stream. So Rust toolchain, yeah, and we have .cargo/config.toml. Here we're actually using the Rust LLD linker.exe, Rust flag z chair generics equal to n-z threads equal to 0. So I actually took this from a place. Let me show you where exactly I got this. And I actually only set up Windows. You could check out your own platform later on. But let's see where I found it. Bevy GitHub. And I think config fast build. I don't know. Let's see. Let's see if this is the one. Okay, so .cargo in the Bevy GitHub repo, config fast builds.toml. So there's all this stuff. I actually took the Windows configuration. There we go. So this is what I copied over. So, but you need to actually install this stuff. So cargo install -f cargo bin utils. You need to make sure this is updated. And then you need to make sure that you have the LLVM tools by also running this command, rust subcomponents add LLVM tools. So, and then of course the Rust linker. And then I commented this stuff because I'm using the nightly version of Rust. Though there is one problem with this for whatever reason. They're using the N here, which that didn't work for me. It actually told me like there is a lot of exported symbols for some reason. So to fix, well, what the heck? Did they fix it or something? I don't know. But I believe this was Y, like instead of N. But then I fixed it by making it N. I'm not sure what the heck happened here. Anyways, so that's basically it. How to make compile times and runtime faster with Bevy. Perfect. Now here I just have a little simple 3D example from the Bevy examples. So default plugins, and I also add in, oh yeah, so to add that inspector plugin, right, you just add Bevy inspector EGY here, and then you add this stuff here. So add plugins, world inspector plugin new, and of course you import it. And yeah, here I just have a little example pretty much. And that's basically it. So that's what's the setup that I have here. I actually set this up before the stream because of, you know, the compile times and so on. So that's great. Anyways, so let's actually get to work right now. So I'm gonna, well, ideally I would actually have my plugin and this example thing here in two crates, in two separate crates. But for now, just to keep things very simple, I'm gonna actually develop the plugin inside of here. Later on, then we can actually split it. Why not? So let's actually make a new folder. Let's call this, I guess, Lua plugin. Lua. Well, let's, should we call it scripting plugin or Lua plugin? Let's call it scripting plugin, okay? Or, yeah, well, hold on. Bevy Lua U plugin code attacker Bevy. Oh my god, let's just call it shit. Anyways, scripting plugin like this, I guess. All right, let's make a new module here. So mod.rs, and let's actually do this. So struct, and I'm running out of oxygen right now. Bevy compiling really heated up my room. Anyways, so struct, let's see, scripting plugin. All right, cool. Now we're going to implement plugin for scripting plugin. Well, first of all, I need to add this module into my main RS here. Use, scripting, well, sorry, not use mod scripting plugin. There we go. And this should be included now. Let's actually use Bevy prelude. There you go, Bevy prelude. And now we're implementing plugin here. I'm going to remove this and I'm actually going to say instead implement missing members. There we go. fn build. So now here we could actually set up our thing, right? Cool. Lovely. So now we need basically some struct for holding our state. So scripting, or let's call it scripting VM, I guess. Or, well, yeah, fine. Just say state, please. Thank you. Now we're going to have lua, mlua, lua. Perfect. Or we could maybe say use lua, well, mlua prelude. Does that include it? Yeah, apparently. Cool. So now here, let's actually create our state. So state is equal to scripting state lua new. And then we're going to insert that resource into the application. Though the problem here is that lua is not send, as you can see. So, I mean, if we actually try to compile this now, it's going to give a better error here. So insert resource. What is the bound? Well, I should actually derive this as a resource first of all. And let's see what's going to happen here. It's going to tell us another problem. All right, there you go. So required by a bound. This originates in the derived macro resource. So it's telling me that this RC mlua thing, like the lua VM here, cannot be shared between threads safely, which is actually true, right? Because it's not send. So it needs send implemented, which is not implemented. So instead of that, what we're going to do instead, we're going to actually insert this as a non-send resource. Non-send resource, and we're going to add it to the application. And that's basically it. Now the next thing is, well, let's actually right now add this plugin here. We could add it here, I guess. And, well, is it public? No, it's not. All right, let's add it as public here. So scripting plugin. Let's actually have default maybe, or new, why not? And let's actually implement that. Can it implement it itself? There you go, cool, love that. Pub fn new scripting plugin. All right, so that's basically how you add it. Now this should compile. Perfect. Now we're actually like initializing our lua state. The next thing that we're gonna need is how we can load scripts, right? So we're gonna have an assets folder for our assets, and then a folder inside of it called scripts, let's say. And let's just make a little example script here that we want to implement. So let's say that this would basically just rotate whatever thing it's attached to, whichever transform it's attached to. So like, I don't know, rotate.lua, I guess. Or rotating.lua. I don't know. Anyways, right? And then it would have like, let's say a function. Walaikum salam wa jigir, and welcome back to the live stream. And it would have like an update function here. And then you would get, I guess, self and the engine, I think. Or maybe we would just get self actually, maybe, I don't know, we'll see. So function update, or honestly, we may be able to even, would I want that? No clue. Let's keep it simple, please, for now. Or, I mean, so, like, do I want to do it like this? And then basically you would have something like this, and then you wouldn't need this anymore. No, that doesn't make sense. Never mind. So we're just gonna have an update function, right? And then basically I want to have something like self rotate and rotate, and then you give it, let's say, a vector, I guess. So in Lua U there is a vector, I think, vector.new. You also supposed to get delta time, yeah, delta time. And let's say maybe something like this, I don't know. Let me make sure to configure my plug, because here I have a plugin for Lua. This is my plugins, by the way, that I'm using. And here I have a Lua language server, right? Okay, how can I actually see the settings, preferences, settings? Let's see the extensions. Lua, where's Lua? Lua. There you go. Now, is there like a Lua version thing or something like that? There you go, okay. So the Lua runtime setting, instead of Lua JIT, well, there's no Lua U apparently. Is there like an actual plugin for Lua though? Lua U? Oh, but this is actually support for Roblox. No, there is Lua language server. Let's see this one. 3 and here 5. I guess let's try this one instead. And for now, let's. Where is the other one? Let's disable this for now. And let's see what happens. It's given me a bunch of issues apparently. A known global vector. Is there like a vector 3 maybe? Yeah, apparently. Cool. Let's actually try this then. Alright, so basically I gotta implement an asset, a custom asset into Bevy game engine. And how I'm gonna do that, well, we're gonna check out some example. Bevy custom asset. And there we go. So we're gonna add a new file here. Let's call it, I don't know, asset, or like, let's say script asset loiter, or just asset, script asset rs. Okay, cool. So this is where we're gonna have that logic. So first of all, we need a struct custom asset loiter, struct script asset loiter, and it's empty in this case. All right, and then we need this error. We need to add this error. So cargo add this error library, and so we can actually add this. Also, let's just derive default to. Yeah, let's derive default here. Let's add this to the module. So module, well, script asset Now script asset, we need to import this error. And there we go. So we only need this, could not parse run. I see, we don't need this, I believe. Let's remove this comment, no need. Could not load script asset. Right, so now what? We also need the asset itself. Let's just copy this, put it here. Let's say script asset. Let's import this stuff. Probably I should say use Bevy prelude. Yeah, there you go. Let's see, and now I also need deserialize apparently. And let's see, quick. Nah, I gotta add Surday too apparently. So let's add Surday, and then we should be able then to say use. Well, it just works apparently. Yeah. All right. Well, not really. So now I could just say control. Whoops. Yeah, control dot, I guess. There you go. Import Surday deserialize. All right, perfect. So now what's next? So now we gotta implement the asset loader trait for our asset loader. So implement asset loader. Asset loader for our script asset loader. And now let's implement missing members. And now the type of the asset is, well, our script asset. Exactly. Settings, nothing for now. Error, it's our custom asset loader error. And now here, what the heck is going on? It's an implement conditional send feature, blah, blah, blah. What? Oh, it should be async, right? Because it have this feature right here. So this is basically async. And let's remove that. It's basically just a result. Self asset, self error. Okay, perfect. Bevy asset IO reader. So this needs some lifetime, and let's just ignore it for now. And there we go. Perfect. So now what's next? So, well, actually we're gonna read this a string, right? So code is equal to string new, and then we're gonna say reader dot read to string mutable code, though this is async. So, well, what the heck, what's the error? Can I say okay here real quick for a second? All right, what's going on here? All right, so read to string mutable code await. Perfect. What this returns? Does it return anything? Read to string future. That's it. Okay. And then we could basically construct our asset. So our script asset, well, what basically contains the code string as a string. I mean, we could try to actually compile it using Lua, but no need for now, at least. Reader read to string mutable code, and let's actually implement new here. So like impulse script asset, yeah, function new. Perfect. And let's just go here and create the asset. So just okay script asset new and give back the code. Now we're not using settings, so let's prefix it with that, and we're not using the load context either. Now let's just make sure everything is compiling correctly for now. Well, let's make this mutable. And is there anything else? Let's try to compile this real quick. and perfect. So I think that's basically it. Now we just gotta basically initialize the asset and initialize the resource and so on in the actual plugin. So let's go ahead and do that. Let's go back to our mode RS. And here, yeah. So insert non-send resource dot initialize asset. So how do I do it? I think I do it like that, right? Script asset. Oh, it's not public. So let's go back here. Let's make this public and probably the asset loader true. And let's go here now. Script asset. There you go. Dot init asset loader true. Our script asset loader. And honestly, instead, well, it's fine. Yeah, it's good. All right. What else? I think that's basically it. To add the asset. Can't leak private type. Yeah. So we should make that public too. So which one? This one. So our custom asset. Well, I should call this script asset loader error instead. Pretty much. There you go. And yeah, that's basically it. Cargo R. And if that compiles successfully, then we actually have initial, like we have made our script loader. Though there is still one thing missing actually, which is the extensions. So there is another member here. And there you go. So here you basically can give extensions of the asset loader. In our case, it's Lua. Just one extension, Lua. Right? Or actually, it may be Lua U though, but anyways, whatever. In fact, let's try it. Like, if I actually said Lua U instead, would this still work? I guess. So, So I guess then let's just use Lua U then instead of Lua. Alright, perfect. So now what we're gonna do? Yeah, let's actually use right now our asset loader to load this script right here that we have made. So let's go to our application, I think, yeah. And let's try to load this. So to actually load it, we need to have a system called setup. I mean, we already have a system called setup. We need the state. Oh yeah, we actually also need the system components, because when we're gonna load the actual asset, it would give us back a handle. Now the thing is, if we don't use that handle, if we don't store it somewhere, if it's not used by some component or entity or whatever, then it's basically gonna be destroyed, like it's gonna be unloaded, right? And we don't want that to happen. So we also need the script component already. So let's go to our plugin, scripting plugin. And here we're gonna have, let's say, pub struct script. Well, yeah, script component. And it's gonna have a handle to our asset. So asset is a handle to a script asset. It's probably going to contain some other stuff, but for now this is it, right? And of course we're going to derive derive component, so we can make this a component. Perfect. Now what's next? Let's actually, did I initialize? No, it's good. All right. So now what we need, okay, so we got the state, where is it? Setup, right? So we got the states, which is basically our components, or like assets to actually, yeah. And then the asset server. Do we have the asset server here? No, we don't. So let's just create a new system called setup scripts, I guess. Right, and this system would need commands to actually spawn stuff, right? So mutable commands. And we need the assets, the asset server. So let's copy the asset server here. And now let's see what we got. Can we do this? So we got script handle is equal to asset server.load script.lua u, and from the extension it would basically realize that it actually needs to use our own loader. And then commands.spawn script component. Well, first of all, let's actually implement a new function for our script component. Implement script component. Let's go fn, well, pub fn new, and you just get the asset. Perfect. And that's basically it. Now let's actually make use of that here, and let's make sure to import this guy. And there we go. Perfect. So now this would basically go ahead, ask Bevy to load our script, and then we could spawn it as an entity, right? Now the problem is in Bevy everything is async. Well, I mean the asset loading is asynchronous, meaning that yeah, we have added our script, but it may not have, it's probably actually already, like, it's not loaded yet, right? You just get a handle like directly to, so we could actually use it in the construction of components and entities, but it's not really loaded yet. Now to actually see if it's loaded, well, we're gonna have another system which basically goes through the scripts and check if it's actually loaded. If it is, then we can actually start running the script. So how are we gonna do that? We're gonna have a query of components. In our case, in here they're using state, but for us it's script components. And then our custom assets, which is basically REST assets script. And yeah, that's basically it. So let's actually do that. We're gonna have run scripts or update. Yeah, fine. Run scripts. And so we're gonna have a query to a script component. We're probably gonna need mutable access to this. And what else? And of course we're also gonna need our assets. So assets or script assets is REST assets script asset. There we go. Where I'm actually putting this. Now, no, I'm not gonna put this here. I think I'm gonna probably put this in the plugin, not the application. Because this, I think, should be the job of the plugin. So let's go here and let's do it here. And let me add this system. So where I'm gonna add it? Let's add it here, I guess. So add systems. And here the schedule that we're gonna use. I'm not sure about that, but let's just go with updates for now, I think. But that could be different later. Anyways, so run scripts. Perfecto. Now, does not need to be mutable. Okay, cool. Now let's see what we got here. So for mutable script in query iter mute, then we're gonna try to get the asset. Now this would basically, this get function here would give you an option. If it's not yet loaded, it's gonna give you none. If it's loaded, it's gonna give you some. So what we're gonna do is, I'm gonna take this and I'm gonna say if let sum, to make sure it's actually loaded. Let's remove this in wrap here. If let sum, well, my bad. So some script asset here. Or actually, let's just say, yeah, it's fine. Let's just go ahead and do that. Let's remove this in wrap and let's go. So we're checking if it's loaded. Now what happens if it's loaded? We're gonna grab the code, yeah. And what's going on here? It's private, okay. Nah, let's make it, I guess, into public function code, self.code. All right. Now, can you try to do that again? Yeah, perfect. Let code. Now, all right, cool. So now we actually have access to our code. Let's actually try to debug that code and see if it all works out. The other thing though, hold on a second. Script/script.lua, because we put it there. And let's actually try to run this, but we haven't added that yet. So let's add that too. Oh boy, GitHub Copilot is still using the previous version of Bevy. Setup scripts. Whoops. I'm not sure, but yeah, whatever. Anyways. Cargo R. Let's see if this works. Path not found, apparently. Assets/script/ oh, it's not script.lua, it's rotating.lua in this case. Rotating.lua. Let's see what we got. As you can see, every time it's actually right now like printing the actual code of our script. But since this is an update function, and we do need an update because we don't know yet if the script is loaded or not. So we have to do every frame to check, to pull basically. I'm not sure if there's like a better way. There is an event reader for assets to like get an event that a script got loaded once. But the problem with that, you're still gonna need the system to run an update to pull the event reader, which is strange. I am not sure if there is a better way, but for now, this is what I know. So what we're gonna do is, I think we're gonna add, now there's two ways of doing this. We could add to our script component a Boolean value called like, is the script loaded or not? Or is it running basically? Otherwise, we could add another component to indicate that it's actually running. Let's actually see if the component way of doing things would work, because if that's the case, that would be way more efficient, I think. I'm not sure, but we'll see. Anyways, so pub struct running script. And let's actually derive component. So for now, this is just like a marker that this script is actually running. Perfect. Now here, well, not here, in the system here, we gotta make sure that this is not running. So without running script, I think, right? And then afterwards, what I'm gonna do is I'm gonna actually say script.insert running script. Is that work? Does that work? Insert. Oh, maybe I guess I need to get the entity. How do you do that? Well, I think I need to get the entity 2 here, probably. Probably I'm gonna need mutable access 2 there. But that's problematic. I think we're gonna make this a tuple. Does that work? It is not a component. What do you mean? Oh, so I guess just like that. Interesting. Now let's see if this is possible. Maybe I do need the commands here too, apparently, to actually do that. That kind of sucks. But whatever. So how I'm gonna do this? So script.asset, Well, here you're gonna get the entity and the script component. Now I think. Well, mutable. Mute must be attached. Okay. Let's just make it here. Let's go. So Control Alt. Okay, so we have here an entity and we got a script component. Perfect. Now, can I actually use that entity to insert a resource to it? I think I need the commands too, right? Yeah, probably. So let's add the commands. So how do you add the commands? I think like this. And then maybe I gotta say commands.insert. Well, entity. Insert running script. Is that the case? I mean, it seems to be okay. Yeah, seems to be okay. And insert running script. Though, yeah, let's see if this actually works. I never actually done this. Well, what the heck? Oh boy, let's clear and cargo run. Well, how do you actually do this in Windows? I think with the semicolon, yeah. Alrighty, let's see what we got here. Invalid system configuration, add systems. Run scripts, right? I think the commands probably should be like this. I'm not sure. Mutable commands. Yeah, perfect. Now let's see if this actually works as intended. Well, it's this time it's not printing anything at all, apparently. What? Oh, my bad. We removed the debug code here. Okay, so this time it did indeed like do it just once, which is great. Perfect. Now I could have easily avoided all of this crap and just like added a boolean value to the script component to indicate that, and then basically here do an if condition and see if it's loaded yet or not, or like if it is running or not. But the problem with that is that we're not gonna use the ECS system to basically have the running scripts in their own system without that filtering logic, you know. But yeah, so like we're basically making the ECS system do its own filtering, which should be more efficient. At least I think so. Take my talking with a grain of salt. Anyways, let's go. Now we can actually have another system like which does just the updating stuff. But yeah, now what we're gonna do now, here we actually need to run the script. So honestly, let's call this Lloyd scripts instead. But no, hold on. No. Now the thing is, here we're gonna need, what is it called? We're gonna need the state, the luau state, to actually call code, like to run code, first of all. And second of all, we're gonna need, in fact, I think we're gonna need mutable access to the world here. Exclusive access. And what else? Well, let's start one by one, okay? Let's start one by one, fine. Though, honestly... yeah, let's just go. How are we gonna do this? So we're gonna get the resource. So Lua... what did I call it? Scripting state, okay. So the scripting state resource, though it's non-send resource, non-send scripting state. And then, can you release the previous ones? Gria Bing, welcome to the live stream. The previous ones, I kind of hit the wall with them because there was some weird bugs with Bevy. And I'm not really a fan of its implementation. One of them is like, one of them is using in safe code, and the other is like, I implemented one with coroutines, which use it in safe code, and the other one, it was kind of clunky. It was my first implementation. So this is hopefully gonna be the one that I'm gonna release if everything goes into plan. So yeah, hopefully that helps. All right, so let's see. So scripting state dot lua dot yeah, we're gonna load this, okay? So load the chunk, we're gonna load the code and exec in wrap. Well, not really exec, but we could start there, maybe. So here, let's say we have a function start, right? So function start, and rotating script started, I guess. And it's probably gonna need self here. Okay, perfect. All right, let's just see what's gonna happen if I do this, in fact. So it's gonna execute that code and see if it compiles. I mean, no errors, so I would guess yeah. Unless maybe if I haven't added the system yet. Well, I did add it, so that's great. So, but right now we just have to call that function, yeah. So how are we gonna do this? How are we gonna do this? So the start function is basically lua.globals. Well. Let's grab Lua first of all. So scripting state, so instead of doing this stuff right here, let Lua is equal to scripting state dot Lua. Now instead of this grab, I could just say this. And now here Lua dot globals dot get the start function. And now what's happening here are incorrect. No, let me just do it myself, please. Get, and here I need the key. which is the start function. And then I'm gonna need to give it, what the heck is this, which is basically a lua function. Perfect. So here we're getting the start function. Now we could actually call that start function. And what the heck it's saying there, I don't know. Call with the arguments. For now, let's not pass anything. Okay, what's happening? Type annotation needed. Sure, so I think I need to give it the return, which is going to be nothing for now. Let's try to run this now. It should print right now. Hello, like, should print rotating script started. There you go, rotating script started. And let's actually remove that debug code thing. Let's remove, where is it? There you go, here we go. Let's remove it. All right, perfect. Now we need to pass in self, because right now, of course, it's not passing anything, it's passing nil. So if you actually print self, it's gonna give us nil. Yep, there you go, nil. So now we need to construct this object here, and it's gonna be a user data object. So how are we gonna do that? Good question. How are we gonna do that? So let's have a struct self. Well, let's not call it. Let's call it lua self, I guess. And that's basically it for now, maybe. Okay. And now this should implement user data. Lua user data for lua self. Now what we're gonna do is pass in that call, like, so call, and we're gonna like make that self thing. But hold on, before that, I want to create a scope, I think. But you know what? Let's just do this. All right. So let's self. Well, lua self is equal to lua self, and then let's give it lua self here. And that should work because it's a user data. It does implement Lua user data. So we can actually call the Lua functions with it. Now, this is supposed to give me the address of the self user data. Let's see. And there you go, rotation script start, and Lua self is the address right there. Now, the problem is that we have is the fact that the Lua functions, we don't know exactly what it's going to look for, you know, or what it's going to do, or what it's going to need, you know. Like, we don't know if it's going to need the commands, the spawn stuff, or what exactly, or some resource. So for that, we're going to need actually exclusive access to the whole world, right? Because we don't know exactly what the Lua script would do. So instead of taking all of this here, what we should actually do is get mutable world, the whole world. So exclusive system. Now what's going on here? Missing type variable should have a snake. What? Oh, my bad. World, mutable world. Okay. Now the problem is when you actually get the world, you can't get anything else from here as arguments, okay? You have to actually get it yourself through the world because this is exclusive access. Okay, cool. Now we need to actually get all of these systems ourselves manually. So how are we going to do this? Let's start, I guess, by the scripting state. For the scripting state, we could just remove it from the system because it's non-send. You can remove it from the system and then insert it back when we're done. So we don't have problems with multiple mutable borrows of the world. So yeah, I mean, we could have said let scripting state is equal to world.get non-send resource, right, like this, and then we say scripting state.nwrap. But the problem here is we cannot get access to the world mutably anymore, I think, right? Actually, what? Huh. Maybe not. Maybe it's actually fine. Interesting. That's weird. All right, fine. Let's go with it. And the next thing we're gonna need is commands. Let's try and do that. Get resource. Let's just get resource commands for now and see what's gonna happen. So is not a well, actually no. World, to get the commands here, I actually need to say, I think, get commands directly. No. Huh. Well, since we have exclusive access, I think we don't even need commands at this point. We could just spawn stuff directly, really. So I guess then world.entity directly like this? No? In search. No method named in search for in the current scope. Yeah, there is not. Maybe insert mute. Yeah, entity mute. Perfect. And what else? Now we need also the scripting assets. There you go. And what else? Now we also need the query. Query mutable without component, without, huh? Well, I think we probably just need the same exact thing that we have done here. Whoops. Maybe. Well, apparently it doesn't seem like it, I guess. Yeah. So is there like a without here then? What? So how can I do that? Maybe strange. So this only gets one generic, right? Yeah, I think so. So can I maybe do it here? No. So what the heck? Maybe I have to do it like this. No, either. Really? Is there some good examples for this? Query filtered. So it gets query data. Gives back query state. Well, what? No, I mean query. Oh boy, I'm very confused. So query data, yeah? Oh man. where is that with and without stuff? There's this query filtered. Oh, maybe I need this query filtered then. Yeah, probably. Oh. Alright, let's go back here. What if I said query filtered then? And then basically have done... Yeah, and then basically say without running script. Can I do that? Okay, so I guess that works now. That's cool. So query basically calls query filtered, but with that unit type, which is interesting. Cool, cool, cool. Now this iter mute would need access to the world mutably, isn't it? Now, cannot borrow world as mutable because it's also borrowed as immutable. So this actually takes immutable, which is also bad for our case. But if we actually remove the nonsense resource from the world, I think we're not gonna keep a borrow, right? Or no? I guess. Yeah, it works now, I guess. Yeah, pretty much. And then we could basically insert it back into the world when we're done. And what else? So the script asset, I think the same exact thing. When I remove it, and then insert it back into the world. Kinda sucks, but I don't think we have another way. Now, does this actually compiles? Cannot borrow world as mutable more than once at a time. First mutable borrow occurs here and the first borrow later used here. I mean, that makes sense actually. The thing is, we're iterating through the world. At the same time, we're actually trying to insert an entity into the world, which not great. So we're also save this here. But the problem is, how are we gonna do this then? I think we probably want something like commands. Yeah. Can we actually use that? And does it fix our problem? World mutable borrow occurs here. Oh boy. Creates a new commands instance that writes to the world. You know what? I think we should. But like this would actually. Hold on. Maybe I could like get the world's commands beforehand. No, that doesn't make any sense. Yeah, you know what I'm gonna do? I'm just gonna store the loaded ones. Or like the running scripts is equal to vec, or the running entities, I guess, is equal to vec new, and then now I just remove this and just say entity mute really. insert that stuff directly. And then we're basically gonna add running entities dot push entity. Let's make this mutable. Can we do that? I think we can. And then after that, we're basically gonna say running entities, well, for entity in running entities, or the entity mute, insert running script. Perfect. Now. Currently we don't need mutable access, but whatever. Alright, so I guess that's how you do it, right? Let's see if this works. So right now we're basically, all of this works just to actually right now be able to use the world exclusively. And that's great. Now we're good. Now the thing is, Lua self would need access to mutable world, right? So world, mutable world. But of course that means it would have to have be constrained by the world lifetime, which means this Lua self can only live as long as this function here, right? Okay. Whoops. That's not what I meant. Let's do this. Perfect. Now you can see here, well, let's add Lua self, fine. Let's implement new for this. Why not? Fn new world, mutable world. We're also going to need the entity that thing is using, in fact, that is attached to, basically. So Lua self. So we're going to need the world, and we're going to need finally the entity. Perfect. World and entity. Now let's actually construct Lua self. And no. Now this should give a problem, I think. Well, first of all, implement Lua self here. Let's add that. Huh? Okay, let's actually say world here. Well, let's declare that. So basically self would live as long as that. Does that help? What? Okay, that seems to be fine. Alright, cool. Now can I run this? Of course not, because borrowed data escapes outside of function, world escapes the function body here. Alright, so how we can fix this? Basically what's happening here is that Rust is not allowing us to do this, because world live as long as this run script system, right? But if we actually called the Lua with our self, or Lua self, which contains the world, what's going to happen is that we're going to leak our self to like everything, everywhere. It's like the lifetime could be anything. Luckily, there is actually a solution for this, which is to make sure that this self right here wouldn't, at the same level, it wouldn't escape this function here, right? So it would only be a parameter of this, and you would only be able to use it inside of this function right here. So how are we gonna do this? We're gonna use something called a lua scope. It took me quite a long time to figure out this stuff myself. But here we go. All right, so how are we gonna do this? Da da da. Well, I think we can do it here maybe. Well, like scripting state dot lua dot scope. Now here we're gonna create a scope where we can actually do the temporary values. So what's up? Expected to take one argument, lua, I think. Now hopefully we could do all of this right there. Now of course we gotta construct this lua self outside of here. So it should live as long as the scope, or like longer than the scope. And yeah, let's just say this really. No method named globals found for mutable reference scope. Interesting, huh? Really? What? So it can't actually load stuff. Can it get globals? It can't get what? Oh, it can only create stuff. That's strange, but let's see what's gonna happen here. So what's up here? What the? Really? So I think if we don't have this, then there would be no problem, right? Yes, correct. I think we basically gotta say let lua self is equal to scope dot create user data, and then give it lua self. Correct? I think so. I think that's basically how it should work. Can I actually just do it right around here? Doesn't seem to like it though. So I guess then we're good here. All right, let's see if this works. Oh boy, second mutable occurs here. We're never done, I guess. Cannot borrow world as mutable more than once at a time. Oh boy. I guess we're gonna do the same exact thing that we've done earlier. Yeah. I think so, yeah. Yeah, in fact, we could do this stuff here in the running entities. For real, yeah. That actually makes all sense, honestly. Like, I think. Script asset.code. Well, can't I just get it here? Hold on, go back. Go back. Give me this whole thing, please. And here, I'm just gonna say running entities dot push entity. That's all I'm gonna do. And then do this stuff. Cannot find script in this scope. Okay, let's actually add the entity and the script. Cool. Now here we're gonna get the entity and the script. Now honestly that makes total sense right now, because we don't want to be iterating mutably over all the entities while also adding entities and stuff like that. This type, this argument has type Bevy prelude. What are you talking about? Entity script components. So what's the problem then? Huh. Also, let me just make sure that I'm making this clear. So first of all, I got the entity and script component. Though to be honest with you, even the script component, I'm not sure if we really need that. No method named push found for what? I'm confused right now. I see. Well, this should be a vec actually, like this. Alright. Expected tuple. Alrighty. Well, in fact, no, we don't want this anymore here. World.entity mute insert running script. Can I actually do this here too, or? No, I think I could remove this entirely. Yeah, that seems about right, I guess. Let's see what is the error. So first mutable borrow occurs here. First borrow later used. Oh, I see. So I gotcha. So we don't want really the script anyway. So let's just give the code instead. All right. So if let's or let's just say this .get script asset. Yeah. So let's do this and then .map getting like the actual code. Exactly. Though without the inwrap. And now instead of this crap, I could just say, so this is right now the actual code, but no, it still have a reference there, I think. But let's just see what's gonna happen anyways. So if let's sum code right now is equal to code, then we don't need this stuff anymore. And let's try now. First bar later used. Maybe I should actually clone that code. Hold on. So I don't hold the reference of the iterator anymore, I feel like. So well, honestly, just say, oops, map so now I actually have option and string with entity, which is great. Now, is there any other problem? I think here, which we could actually do here. And use result that must be used in wrap for now. Does it compile now? Oh boy, feels like a puzzle. But like a lot of those things are actually valid concerns that you would have easily overlooked without the borrow checker. Like I would have been actually mutating the world while the script also mutated the world, which could easily end up in a disaster. Fills word and entity are like basically I'm querying over a vec, like I'm iterating through something but also adding to it, basically I'm mutating it, right? So I'm iterating through something that I'm mutating, which is not a great idea. So then we basically add an indirection. We actually just store the stuff that we want to process, then we go over it later on. Yeah, I feel like right now we should be good to go, pretty much. Yeah. So now what we want. Well, what we want. What we want. Let's forget about the update function for a second for now. And let's just add it, I don't know. Let's add it here in the start because we haven't like implemented the update just yet, okay? So let's say self rotate. Now the thing is about self rotate, I mean, all right, fine. Let's just go ahead and do that, honestly, fine. I don't know, let's say math.pi/2 maybe. And yeah, let's go. Now we need to implement the rotate function in self. Let's do that. All right, let's go here. And let's implement default members. Now we don't want this, but we probably want this. For now, we don't even need this either. So let's go. All right, this is crazy. Methods.add. Hopefully nothing crazy happens right now. Add method mute. Do I really need mute? I'm not sure. So the name is rotate. And the method is, oops. Yeah, I'm probably gonna need mutable. But we'll see anyways. So here I'm probably gonna get, well, let me see what the AI would say. Fine, let's try that, I guess, and see what's gonna happen there. Yeah, we're getting this, which is the Lua self. And here the Lua state, and then the parameters. The parameters, though, it would be just like a Lua vector. Well, vector, or like, yeah, vector. And then let's see what the AI would say here. transform.rotate vector dot no, I don't think it can do that. Like, just say vector 3 new and then extract the components, I think. So it's basically getting mutable transform from this dot entity, and then transform rotate from rotation y. Use if in declared type. Quick fix. No, I think it's called vec3, not vector 3, right? Mismatch types expected F32. Oh, damn. I see. I see. So this is not the right one then. Yeah, not the right one. From rotation. No. Can I say from Euler? Euler rot. X, Y, Z. And now here I could actually give it the values A, B, C. Now what's wrong? Attempt to take value of method X on type method, not a field. Okay, so it's not a field apparently, I guess. So dot X like that. Would that work? Does that work? As it is behind. Okay, so now we need mutable method actually. And does this work? Good question. I think it's time to find out. So yeah, this compiles, right? Yes, it does. Perfect. Now it's really time to find out. Let's see. So let's say we got our cube. Okay, we want to attach the script to it. How are we gonna do that? So I think you basically, well, am I even creating the script component? Huh? I don't think I am yet, right? Or no? Hold on, where am I actually creating the component? I lost track of that. I don't think I am yet. Like, who's using this? Is there anyone using this? Okay, there you go. Setup scripts. Oh, I see. So no, we want this in the application, not here. Let's put in the app. Where's the application? Oh my god. Main RS. Setup scripts. Well, in fact, we already got the commands here. And let's just add the asset server. Hold on though, no. The problem with setup scripts would be an update. I see. I see. So let me grab that thing. Hold on. Well. Where the heck was that? Okay, who was using setup scripts? Come on. Oh, it was actually in the right place. Yeah, my bad. I see. So now we basically got to keep track of which entity we want to actually attach this to. So like we want the cube, we want the cube to attach to the cube. So we need somehow to track the entity. And I think how we're gonna do that is by having a struct state, right? And our state would contain, like, let's say the cube entity. Cool. So this would be our resource, basically. So add resource. Well, What? Insert resource then. All right. State. But oh well, we don't know what is that entity yet. Is there like some sort of invalid entity or something? Or I don't know, like some default entity? No. So then we have to say option then, to make sure the entity is actually added. If it's not, that's going to be problematic. But anyways, cube option none, or like let's just say state derived default really. And here what we're going to say, none. Oops, what's up? Actually, what the heck I'm talking about? No. I think, hold on. I think I have a better solution. My bad. Let's see. So what we're actually doing here. Well, actually we could use it already, yeah. It just gives us the handle, my bad. Yeah. So I see. But like, yeah, the problem that I had is the fact that we're gonna need to... Now the problem that I have is setup scripts actually... No, it's actually in the startup. I see. Never mind. So let's just take this asset server first. Kind of overthought it right there, overthink it, right? Anyways, let's go ahead. So we basically load the script, right? Cool. And then we just pass in the handle. So we attach that script component to everything, to anything we want. Now, in our case, we're going to attach it to the cube. I think that's it, really. Yeah, I think that's it. Alright, let's see if this first of all compiles. And come on. And it actually does. Now, the rotation of this cube, what is it? Like the initial rotation, I think 0, 0, 0. Let's now cargo run and find out if this would work. Oh boy, panic. Where? Attempt to index nil with new. Runtime error. In line 4. I think it's talking about here. Well, vector 3. Oh, then, like, how do you actually create a vector? Hold on. Attempt to call a nil. What? Really? That's strange. How do you... Hold on a second. Well, in G, yeah, do. And print IV. Alright, so this is the stuff that we actually have in the global table. So we have lua self, we have some string like standard library XP call package, 2-string GC info OS type off require, get film set meta table next assert raw len to number raw equal collect garbage, get meta table UTF-8 vector. There we go. Alright, so what about .g.vector? Number expected got nil. What the heck are you talking about? Line 5? I think it's probably called vector then. Let's see if that works. That actually worked, but let's see if it have ran as expected. So we have here a PBR mesh. Does it have the script component? No. There you go, script component. Perfect. Now, what is the transform of this? The rotation is, it works. All right, so it actually fucking worked. There we go. So without this, like right now, as you can see, it's pi over 2. But this is not very exciting because, you know, just having the start function. Okay, so let's actually implement the update function now. That's gonna be way more exciting. And yeah. So how are we gonna do this? Good question. I don't know. Run scripts. So let's subtract first of all something here, which is so we got exec and wrap, globals get, create user data, lowest self, and then start.call. Well, yeah, let's just go ahead and see what we're gonna do. So you're gonna have an update scripts function, of course, and this would also have like exclusive access to this thing. So world mutable world, and let's see what we're gonna need here. First of all, we're gonna need those resources that we need. Well, actually, hold on. Of course, we're gonna need the scripting state, that's for sure. But let's make sure to actually insert it back into the world. That's the first thing. The second thing is, are we gonna need script assets? I don't think so. No, probably not. The query, we're gonna need a query, yeah. But this time with running script. Instead of without, we're gonna say with running script. And what else? We're probably gonna have a similar thing here too. So we're gonna extract the running entities first. And there's no need for the script component actually. I mean, it should have a script component, but we don't care about it. Right. We probably gonna need that, yeah. Yeah. You're gonna need it later on for the environment, custom environment, I think. Yep, so right now we're actually, this wouldn't work on multiple components. This is using the globals, right? Let's actually implement this first, really, because it's very important. Because the problem is right now, if we actually add this script component and we use the same script in like multiple places, in fact, like whatever, like if we use multiple scripts, this wouldn't work. Why? Because we're using the globals here, right? To like, where is it? Yeah, well, actually it should work. Hold on. Confused now, hold on. Well, we are actually creating user data. Huh. What? I'm confused. Well, then maybe it would work. Because I'm not really mutating the globals. I'm actually passing it as an argument here. True. Let's see what's gonna happen anyways. So apparently I guess we don't need the script, right? Script component. And in fact, since it does have a running script, then it's for surely have a script component. So then I don't think I even need that, really. So like I guess I could just say this. Yeah. And then I only require the entity. Well, we'll see what's gonna happen. Push entity only. And now, after that, well, let's see. So, no, just entity there. Scripting set lua. Well, actually, I think I am actually. Well, no, I'm not. Hold on. Get update in wrap. Create user data, lua self in wrap, and then we're calling that with the lua self. Yeah, I think that's perfect. Yeah. Let's try this out. Let's try this out. So, I mean, it also would be update. Okay, is that good? Now, hopefully what we could do right now is take this from here, put it in the function update. Though we do gonna need something else in a second, but for now we could just hard code it. Like instead of this, let's just say some small number for now. And let's see, well, let's just print update to make sure we're actually updating. Yeah, let's see. Would this work? Let's see. It does! There we go! Nice! Oh boy, we made it. Let's go. Alrighty. That's pretty cool, pretty sick. Jack, welcome to live stream. Love this project. mlua plus Bevy seems like an obvious pairing. Yeah, for real. And there you go, it actually works. Man, all that borrowed chicken problems. Finally, it actually works. That's pretty cool. So it's kind of like Unity. I kind of designed it like Unity and stuff, where you just like, you know, you have your script code loaded. And then as an asset, right? And then you could create a script component to whatever stuff here. And there we go. Will this be on GitHub? Yeah, for sure. It would be. Next, rotate camera with mouse. I want to test this if it actually works correctly with multiple instances. Hold on. Well, first of all, we actually need to set up something, which is basically here. This is not great. It needs to get the delta time, right? And then we could actually use it here. Now let's see how we could actually get this. So here, update function, lua self, but we need the time resource basically. So let time is equal to world.getResourceTime. And then here we're gonna say time.delta seconds, basically, dot in wrap. Oh, no. So this expected one argument found 2. Oh yeah. It basically needs to be like this in a tuple. Yeah, let's actually remove it, really. There's just no way out of that. I did some stuff with EGY node graph earlier this year. I kind of want to extend this with that node graph editor code. Yeah, that's very interesting. There's just a lot of things that I want to actually experiment with too. That would be amazing. Let's make sure to insert it back into the world. Yeah, actually let's insert it first. All right, what else? So I think we're good now. So now it's actually correctly using that thing. We don't need the printing right now, please. Cargo R. And that's perfect. Let's add some more cubes. Let's add a second cube, let's say. And that cube. Let's actually put it up a bit there. Let's say, I don't know, 2, maybe. Oh, well, basically they're gonna share the same resource, the same script code. Well, we need to clone it actually here, so we could reuse it there. Now we have 2 cubes using the same script component. Well, not the same script component, but like the same script, basically. Let's spice this up a bit. Let's say math.random. Math.random, and I think, yeah, you give it 2 numbers. So here we're gonna say -1, 1. Oh, no, not every time. Well, let's say local x is equal to math.random, and then use that x there. So we do it once. I guess we're lucky there. Or isn't it? Oh, maybe. Uh-oh, I think we have a problem here. Yeah. Alright, what if we actually say then local x, and then x is equal to math.random here in the start function. Yikes, I think I know the problem. Yeah, we need a custom environment. Like every component should have its own environment. So right now what's happening is that all the components are actually sharing the same freaking environment. That's why, so this X here is actually shared. That sucks. So let's actually fix this, yeah. And I think I know maybe how to fix it. I don't know, we'll see. Oh boy. So the running script. Okay, we're gonna need some stuff here. We're gonna need an environment, which is gonna be a Lua table. Right? Cool. But it doesn't like it. Why? Because Lua table is not send. Oh man. Can I do RC like this? Sorry, arc. Would that help? It still doesn't like it because the trait sync is not implemented either. So we gotta say RW lock then. Does that help? STDRC weak. Well, that sucks. It doesn't seem like it's fixing it at all. Luckily, we do have an escape hatch. So let's remove that stuff. And instead, what we're gonna do is we're gonna add mlua. We're gonna add it to a feature called send. This is gonna decrease our performance a bit, but I don't know how we can do this otherwise. There we go, we added the send feature too. So now this should work, I think. Let's wait for it to load up. And yeah, we don't have that problem anymore, which is great. Now what? Lua table, environment. So how we can access this now? Now here we just were saying without running script. But now we actually gotta say with running. Oh well, where is it? Insert running script, and then we actually gotta give it like an environment. Okay. Here we gotta say entity and running script. Oh boy. Well, we're gonna need. Yeah, we're just gonna share the table, right? So hold on. So entity and running script, I think. Oops, we're gonna actually do this. And yeah, we're gonna need a ref there. Now we got the running script. Now let's actually grab the environment from the running script. Hopefully this works without any freaking problems, please. Environment. Let's actually grab the environment here now. Though well, yeah, let's do that. Environ. Oh boy, how do you spell it? There you go. So is everything okay so far? Oh, well, let's just have a query then. Yeah, let's actually clone it. It would just clone the reference to the table. Yeah, I think this should be perfectly fine, I believe. Now here, insert running script. Okay. I don't think we actually really need this stuff here inside of the scope. The only thing that it should be inside the scope is the create user data and stuff like that. And of course the call. Yeah, I believe this should perfectly be fine. Now here what we're gonna need is the environment. A custom environment. Well, actually before executing the code, we're gonna create a new environment table for this. Lua create table, exactly. And then like after we load the code, we want to set an environment here. Environment. Now if everything goes into plan, this should be good to go. Now insert running script envar. Do we actually even really need that? I'm not sure. Use of moved value environment. But whatever. We probably don't need it right now, but we may need it later on. Anyways, so there we go. Apparently, currently we're not using it. Okay. And that may fix it. Unless if I'm not really thinking about something here. Hopefully it does. Let's see. Come on. Oops, we have a problem. What? Actually that makes sense because we shouldn't use the globals anymore, should use the environment. Ooh, I see, yeah. So we actually do need the environment apparently, yeah. And before I forget, really. But hold on a second, what the heck? What is this? Run scripts. Yeah, that's actually good, never mind. Environment get the start. Now that's the first thing. The second thing is this environment would actually be empty, so we need to get the values of the you know, what is it called, the globals. So Lua globals, so you can get the standard library, you know, for each key value. Environment.set key value. I'm not sure if there's like a better way to actually just clone the or copy the actual table of the globals, but yeah, yep. And I think it should unwrap this here. Key and value, I don't give a shit. Just say Lua value, whichever Lua value it is, I don't care. And I think we're good now. The only thing we should make sure to do here is use our environment instead of the globals. Now this makes total sense. Let's see if that helps. I mean, it's still rotating the same. Okay, so it actually works. Perfect. There we go. There we go. So now they don't share the globals table. every script have its own environment. So that's perfect. Cool. So I think we should be fine just saying this here. Local x is equal to math.random minus 1, 1. No? Yeah, perfect. I just want to get like either -1 or like one of them is rotating in. What the heck? Hold on. Is there like a random integer thing? No. So here's the deal. You're gonna say I forgot how to even program here. Did that help? And well, -1. Well, actually 0. Well, what? So basically, there we go. All right, perfect. So it does actually work. Lovely. All right, so what I want to do next. Good question. I mean, we could implement some more properties like functions and so on. How much time have been? So it took us around 2 hours. Alright, that's not bad, I guess. Alrighty, what we have here. Scope, environment, scope, create user data, luau self in wrap, blah blah blah. Okay. Luau self. Environment dot get start environment. Yeah, that's actually pretty good. I think we probably just yeah, I feel like we just finish the stream here, and so we could continue later on. So that was pretty cool. Pretty cool. I think we could probably do the same thing with the camera too. Why not? Like, I mean, if we do this. Oops. What? Hold on. So basically we want this up to here, this, and then this. Now I added the same component to the camera. Oh boy, script channel.clone. Come on. Okay, so it works on the camera too. That's cool. Alright, so yeah, that was it, I guess, Thank you all for coming into the stream. Thank you for Loop Luminary, Theo Paris, Woji Gearing, Grea Bing, Jack. And yeah, that was pretty cool. Maybe let's try to stage all these changes. What should I call this? I don't know. First working implementation, maybe. Commit, and let's publish the branch. Public repo. Signing with your browser. Come on. Successfully published. Perfect. Would you like to... why not? Open on GitHub. And there we go. We're live. Add a readme. Huh. Bevy luau plugin implementation. Or like integrating. Honestly, I don't care right now. Cancel changes. Just add a like a license for now. Add create new files. Just add a license. Okay. And we're good to go. So let me just give you the link. And let's go. We're done. We're done. Yeah, so that was it guys for this stream. Thank you all for coming in and see you later. Goodbye everyone.